Okay, we're going to look here at what it means to factor using long division. We've got some steps over here to the side that detail the process, and while in reading them they might sound a little bit new, they're really no different than the same steps you've always used when using long division. So for example, if we were to look at does 4 divide into 792, you would start by setting up your division. Right? 4 divided into 792. Next, you'd be looking at finding the terms above by dividing your first term, in this case our 4, into our 792. So if we were to take this 4 and to ask ourselves, well, how many times does 4 divide into 7, aka 4 times what gives me 7? Well, there's nothing perfect that gives it to me, but it's about 1, and so that we'd put a 1 above. And then we'd be distributing each of our terms to our divisor, so aka multiply, right? 1 times 4 is 4. And then we'd subtract our terms, right? We'd be subtracting that 4 we just got. We'd get 3, and then we'd carry down our remaining terms, so carrying down that 9 and 2. And then we'd do the process again, right? Going back to step 2 here. Figuring out how many times does 4 go into 3, it doesn't, so how many times does 4 go into 39, aka 4 times what gives me 39, it's about 9. We then multiply, 4 times 9 is 36, and step 4 we'd subtract, so we'd get 3, step 5 carry down the remaining terms, which is our 2, and you do it again, 4 divided into 32, aka 4 times what gives me 32, that would be 8. Multiply, 8 times 4 is 32, subtract, we get 0, and there's nothing left to carry down. So that brings us to step 7, which is the last term is our remainder. In this case, our remainder is 0. If the remainder is 0, then in our instance, we're going to be looking at x minus c, this thing outside here being a factor. Obviously within our kind of traditional, more elementary school version of long division, the fact that we have a remainder of 0 tells me 4 goes perfectly into 792. If I had a remainder here, that would indicate the presence of a fraction or a decimal if you choose to display that remainder that way. Okay, so we're doing this exact thought process, just we're doing it on functions. Okay, so step 1, we're going to set up our remainder here. We have our division here, x cubed minus 3x squared plus 8x minus 6, and I'm looking to see does x minus 1 divide perfectly into that polynomial. Okay, so step 2, we're going to be asking ourselves, just like we did over here, how many times does 4 go into 7, aka 4 times what gives me 7? Well, how many times does x go into x cubed, aka x times what is x cubed? And our answer would be x squared. X times x squared is x cubed. Okay, then you're multiplying the same way we did the 1 times the 4. Now we're doing x squared times x minus 1. Distributing that x squared in. X squared times x is x cubed. X squared times negative 1 is negative x squared. And then just like we subtracted the 4 after we did our multiplication here, we then subtracted. Same thing here, we've done our multiplication, now we're going to subtract, so this is going to be minus x cubed plus x squared. X cubed minus x cubed is 0, negative 3x squared plus x squared is negative 2x squared. And bring down our remaining terms. So we're going to do it again. How many times does x go into negative 2x squared, aka x times what is negative 2x squared? Well, x times negative 2x would be negative 2x squared. So now multiplying, negative 2x times x is negative 2x squared. Negative 2x times negative 1 is positive 2x. And then we're going to subtract. So this becomes plus 2x squared minus 2x. Negative 2x squared plus 2x squared is 0. 8x minus 2x is 6x. Bring down your remaining terms. Okay, doing it again. How many times does x go into 6x? It goes in 6 times. Now multiplying. 6 times x is 6x. 6 times negative 1 is negative 6. So we're going to subtract. This becomes minus 6x plus 6. 6x minus 6x is 0. Negative 6 plus 6 is 0. And so we've reached the bottom here. There's no way x can go into 0. So we're asking ourselves, does this x minus 1 go in perfectly to my polynomial? AKA, is that x minus 1 a factor? Well, because I have a remainder of 0, it does go in perfectly. And so yes, x minus 1 is a factor. In fact, if I wanted to, which is kind of what we're building up towards, if I wanted to rewrite this initial polynomial as a factored, or in its factored form, this initial polynomial here, its factored form would be x minus 1 times x squared minus 2x plus 6. And in fact, we could look and see, like, does that trinomial factor? If it did, we could factor this some more. Okay? But yes, x minus 1 is a factor because we have a remainder of 0. Okay? My recommendation would be to pause the video, give the second one a shot on your own, and then restart it either when you're stuck or when you have an answer. Okay? Let's go ahead and walk through this. So we have our first term, setting up our division. X cubed plus 2x squared minus 4x plus 3 divided by my second, my x minus 2. We're looking at, is x minus 2 a factor? Okay, so how many times does x go into x cubed? AKA, x times what is x cubed? That'd be x squared. Multiplying, x squared times x is x cubed. X squared times negative 2x is, x squared times negative 2 is negative 2x squared. And now we're going to subtract minus x cubed plus 2x squared. X cubed minus x cubed is 0. 2x squared plus 2x squared is 4x squared. Bring down your remaining terms. How many times does x go into 4x squared? AKA, x times what is 4x squared? Be 4x. 4x times x is 4x squared. 4x times negative 2 is negative 8x. And then we're going to subtract negative 4x squared plus 8x. 4x squared minus 4x squared is 0. Negative 4x plus 8x is 4x. Bring down your remaining term. Okay, how many times does x go into 4x? AKA, x times what is 4x? It'd be positive 4. Okay, multiplying, 4 times x is 4x. 4 times negative 2 is negative 8. And then we are subtracting minus 4x plus 8. 4x minus 4x is 0. 3 plus 8 is 11. X does not go into 11, so 11 is my remainder. And because that remainder is not 0, x minus 2 is not a factor. Because x minus 2 does not go into my polynomial perfectly.